Welcome to AT Math Academy. Topic for today is rational expressions. So, what is a rational expression? Rational expression. So, expression here means expression can have variables and constants. So, anything that is formed out of a variable and constants is called an expression. So, 2x plus 5 is an expression. X by 5 is an expression. And what is a rational expression means? Rational expression means it is of the form P by Q. It should have a numerator and denominator. So if you take this first expression, 2x plus 5 is not a rational expression, but x by 5 is a rational expression. And now I'm going to show you how to add the rational expressions and subtract the rational expressions. So let's move on to the topic. My expression for today is 3 by x minus 2 plus 3 by x plus 2 over 1 minus 5 by x square minus 4. Now I'm going to simplify this expression, and this expression, when you observe, it has the addition and subtraction, and it also has the fractional value in the denominator. So in order to simplify this, I'm rewriting my expression here by taking the common denominator for the numerator. For the numerator, I have two of the denominators, which are x minus 2 and x plus 2. So when you observe here, I have two terms, 3 by x minus 2 and 3 by x plus 2. So in order to add two fractions, we need to find out the common denominator. So it is got by multiplying these denominators here. So my common denominator would be x minus 2 into x plus 2 for this numerator value. And for my first term, 3 by x minus 2, for this term to become the common denominator of x minus 2 into x plus 2, I need to multiply this x minus 2 with x plus 2 for getting the common denominator. So in order to do so, I need to multiply both the numerator and denominator with x plus 2. So x minus 2 into x plus 2 is already here. So I am taking my numerator 3 and multiplying it with common denominator, one of the terms in the common denominator. The missing terms here is x plus 2. So I am multiplying this numerator with 3 into x plus 2. And I have my addition sign here. And I have my variable. I have my constant 3. And for the variable, I have x plus 2. So for the second term, when you observe, the denominator is x plus 2. And the common denominator here is x minus 2 into x plus 2. So for making x plus 2 to x minus 2 into x plus 2, I need to multiply this fraction, this entire fraction, with x minus 2. So the numerator and the denominator needs to be multiplied with x minus 2 such that it gets, this fraction gets the common denominator of x minus 2 into x plus 2, and the fraction remains same. So I'm taking the numerator and multiplying with x minus 2. And I have, now I'm done with the numerator. Now moving forward to the denominator, I have here 1 and minus and 5. And now here, when you observe, x square minus 4, which is of the form a square minus b square. So I can take it as a square and b square, which is x square minus 2 square for b. A square minus b square is a plus b into a minus b. So here my a value is x and b value is 2. So I can rewrite this as x plus 2 into x minus 2. So I'm writing it here, x plus 2 into x minus 2. So moving forward, we are rewriting the numerator x minus 2 into x plus 2, and we'll be multiplying the terms here. 3 times x is 3x, and 3 times 2 is 6, and 3 times x is 3x, and 3 times 2 is 6. And for the denominator part, when you observe here, I have 1, and for getting the common denominator, 1 means the denominator is 1 here. So we need to multiply these two denominators to get the common denominators. So the common denominator for this function is x plus 2 into x minus 2. And when you observe, my first term here is having the value 1. So for making 1 having the common denominator x plus 2 into x minus 2, I need to multiply this entire term with x plus 2 into x minus 2. So here I am multiplying my 1 x plus 2 into x minus 2, 1 into x plus 2 into x minus 2, and minus, and for 5 I can take the 5 as it is, because when you observe in this term the common denominator is x plus 2 into x minus 2. We already have that, so I have taken the constant value as it is. Now moving forward, when you simplify further, when you add the like terms, 3x plus 3x is 6x, and 6 minus 6 is 0, and I'll be left over with x minus 2 into x plus 2. And for the denominator, 1 into x plus 2 into x minus 2, I can write it as x plus 2 into x minus 2, and minus 5 by x minus 2 into x plus 2. So when I take my denominator to the top, it becomes multiplied with the numerator. So 6x by x minus 2 into x plus 2 is multiplied with, when this goes to the top, it becomes multiplied and this gets inverse. So the numerator becomes denominator and the denominator becomes numerator. So I invert the function here, x plus 2 into x minus 2 minus 5. So I have the common terms x minus 2 and x plus 2. That's get cancelled out, and I will be left over with this value. So the final value for this particular function here is 6x by x plus 2 into x minus 2 minus 5. So, and you can also multiply this and simplify further. When you do so, I'm going to take here x plus 2, when it is multiplied with x minus 2, it is of the form a plus b into a minus b. So I can take it as a square minus b square. So for a I have x, so x square, minus for b I have 2. 2 square is 4. So I can write this as x square minus 4. So 6x by x square minus 4 minus 5. So this final value for this particular function is, the final result is 6x by x square minus 9. So this is the simplified form for this expression. So let me explain it once again. Here I am taking the numerator on the top and I am getting the common denominator by multiplying the denominators x minus 2 into x plus 2. And for the first term, I have the denominator x minus 2. And for getting the common denominator, I need to multiply this numerator with the missing term in the common denominator, which is x plus 2. So I have multiplied this 3 with x plus 2. And I have the addition sign here, and I took the another term 3. And here when you observe in my second term, I have the denominator as x plus 2. But my common denominator is x minus 2 into x plus 2. So I need to multiply this fraction with x minus 2, such that the denominator becomes equal to the common denominator and the numerator should be multiplied with x minus 2. And going to the denominator part here in the fraction, 1 minus 5 by x square minus 4. X square minus 4 can be written as x square minus 2 square, and when you apply this perfect square formula, I am getting it as a plus b into a minus b, x plus 2 into x minus 2. And so I have multiplied with 3 times x, and 3 times 2 is 6, 3 times x and 3 times 2 is minus 6 by this common denominator. And when you observe here in the denominator, 1 minus 5 by x plus 2 into x minus 2. So when you take the least common multiple for the denominators 1 and x plus 2 and x minus 2, I get the common denominator as x plus 2 into x minus 2. And for the first fraction, I need to multiply this one with x plus 2 into x minus 2 and minus 5. And when you solve further, 6 minus 6 is 0, so 3x plus 3x is 6x. And I have written my denominator here. And moving forward, when you take the denominator to the top, it gets multiplied with the numerator and this bottom fraction gets inverted. So this denominator goes to the numerator and numerator becomes the denominator. So I have written this fraction like this. And since it is the multiplication part, I can eliminate the common terms. So x minus 2 gets cancelled out and x plus 2 gets cancelled out. Now I am left over with 6x by x plus 2 into x minus 2 minus 5. So when you observe here, x plus 2 into x minus 2 is of the form a plus b into a minus b, which is a square minus b square, which is for a I have here as x and for b I have it as 2, x squared minus 4. So it is x squared minus 4 minus 5. So the final expression would be 6x by x squared minus 9. So this is the simplified form for this expression. The final answer is 6x by x squared minus 9. Hope you all liked my video, and please subscribe to AT Math Academy and enjoy doing math at AT. Thank you so much for taking time to watch my video. Thank you all again.